So,
I don't think
isothermal, positive Q, negative W, what's the value of delta U?
Positive.
What's the value of delta
Zero.
U?
Zero.
Zero. Because what's the value of the change in temperature?
Zero.
Zero. By definition, that's what it means.
Yeah.
Okay? All right, so that's an isothermal expansion. Okay? And we can use work equals nRT, natural log of VI over VF. True?
Yep.
Cool with this.
Sure.
Now we're going to do a horizontal line expansion. So what are we going to keep constant?
The
Pressure.
Pressure. So this is going to be isobaric. Okay, because we're going to keep the same pressure going across. Now let's look at this in terms of PV equals nRT. I'm going to keep the same pressure.
I didn't even say
By definition, that's what that means, right? I'm going to keep the same pressure. What's going to happen to the volume?
Something.
You gotta change.
It's gonna.
It's going to be different.
It's gonna be different, yes.
Bigger?
Yeah,
New
increase.
and improved.
So if the volume's going to get bigger, what has to happen to the temperature?
Get bigger.
Get bigger.
It has to get bigger. Okay? Because we're going to keep the same pressure, volume's going to get bigger, therefore temperature has to be
It's
bigger.
about
Now, we need to figure out what that new temperature is. Okay? So if you look at PV equals nRT, so to find that new temperature, I can take pressure volume over nR. So my pressure was 2440.
Shut up.
The volume is going to be 0.5 cubic meters. And then I'm going to divide that by 8.314 joules per mole Kelvin and 0.1 moles. So Gapshawn or somebody do the math.
The thing you wrote up right
Why?
there.
So 2440 times 0.5 divided by your gas law. By the way, if you want to store that gas law constant in your calculator,
1467.
what'd you get?
1467.
So that's pretty warm.
Oh,
Okay.
Little
That's
toasty.
pretty warm.
Little
So if
toasty.
you
That's
consider the fact that water boils at like 373 Kelvin, this is pretty warm.
This is spicy.
This is spicy. Now, but here's the other thing that you need to look at, and this is this difference between temperature and heat, okay? So just because you have a very high temperature doesn't mean that you have a lot of heat. So here's the classic example. It gets cold, it's wintertime, and the furnace has gone out on your house, okay? You walk in, and you go, wow, it's really cold. Oh, I know, I'll light a match, okay, not to burn down the house, okay? Oh yeah, if I light the house on fire, that'll warm things up. So you strike a match, right? Strike a match. If you put your hand directly above it, you're going to burn your hand, okay? Because that's very, 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 very high temperature. But you're not going to warm up the house because of the fact that you don't have a lot of overall thermal energy in the system. So just because this is a really, really, really high temperature doesn't mean that there's a lot of heat involved. Because remember, temperature is a measure of the kinetic energy. So basically what we've done is that we had that, what was that initial temperature? 293? No, yeah, 293. So we went from 293 up to 1467.
That's 1174.
So our change in temperature,
Just a little bit.
I was able to convince
when you
him
take
that was
1467 minus 293 Kelvin, and you got what going?
1174.
1174.
He didn't even question me.
Okay. Nice. Okay? So at this point, could we calculate the value of, whoa, that got weird. Delta U.
Yep.
Yes.
3/2 NR delta T, right? Okay? That's horrible, but yeah,
As this lesson goes on, your handwriting gets more and more hieroglyphic.
I know. Well, so I got 0.1 moles, I'll try and get less hieroglyphic. So 8.314 joules per mole Kelvin, and the change in temperature was 1174. So what do you get for the value of delta U?
1464.
14 what?
64.
Joule.
3 joules off. What are those 3 joules called?
Okay, cool. Now,
Dark matter.
I want to find the area underneath this line. So this looks surprisingly like a rectangle. What's the height of the rectangle?
Something.
Pressure.
Pressure. What's the width?
Volume.
Volume. Okay? So on this sheet, you've got work equals negative P delta V. So now, here's the reason why you have that outline negative value out in front. So in this situation, I've got, and this only works when you have a constant pressure, and that pressure was, what was that pressure, 2440
Probably.
newtons per square meter. And that's going to be a negative sign out. Now, that change in volume is going to be V minus V naught. So I'm going to go from 0.1 to 0.5. So what's going to be the sign of my delta V? Positive or negative?
Negative.
Wait. Positive.
Positive. The delta V itself is going to be my final of 0.5 cubic meters minus.
Oh, yeah, I did my brain
Right?
did this for the short.
But now, here, this is why this has to be consistent. The volume is getting bigger. What did we say the sign had to be for work when the volume got bigger?
Oh.
Negative. So this is why we have this negative sign lurking out in front. So therefore, we end up with the same sign as if we use the NRT natural log. Okay? So get Sean or somebody take 2440 times 0.4.
976.
976.
What'd you get?
976.
Positive or negative?
Positive. Negative.
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 Negative 1 in the.
Guess you've got that negative sign lurking out.
Sorry,
Okay.
it's kind of hard to tell that was a negative sign.
Now, here's where this all fits together. We know the work value, right? Negative 976. So you also know that delta U equals Q plus
W.
W.
So Q is.
We found the delta U value, right? 1464 joules. And my work value is negative 976.
So Q must be.
So how can we find the value of Q?
Algebra. 400 something.
464 plus 976.
Oh no, not 400 something.
I was just gonna say, I don't know what math you're doing.
Like
1440.
Are you.
What?
What?
'Cause you,
14?
you add it, right?
Yes.
Yeah.
Yeah.
You get
Yeah.
1464 plus 976 is what?
1440.
2440.
1440.
Whoa,
1,000.
When you add 976.
14.
You basically add 1,000 to 1464, which is basically
Yeah.
gonna be about 1,460.
Yeah, 1440.
Yeah.
It's 1440.
1440. 1440.
2440.
I added an extra 4.
Oh,
Wait,
wait.
it's not 24, it's 1440.
No, it's 2440.
There's no way to fill the
1440.
calculator.
Schrodinger's cat.
976.
976.
2416.
What'd you get?
1440.
Huh?
That's a 1464.
That's a four. Oh, that's not. Sorry,
That's not a parenthesis.
That is not a parenthesis.
What did you think it was?
Gershon and I a parenthesis.
That's what I thought it was too for a
What is
while.
it then? It's a
2416. That's supposed to be a 1. It's 1464.
Oh, it's 14. Oh.
I was
2,440.
2416.
I was like, what are you doing?
2,440.
16.
Okay, so let's go back to Cohen.
No, 16.
Okay? So I'm gonna leave Cohen $2,440. That's the amount of energy that I'm
Oh,
going
I
to
did
give him.
1440.
But I'm gonna make Cohen do 976 joules of work with it.
That's okay.
Whatever is left over, he gets to keep.
Oh, really?
Yes,
Sick. Okay.
okay? So that's what's gonna go to increase the energy of the system. So if this was going to play out, water bath, ice bath.
Water.
If I want to make this happen with this syringe,
Hot water,
Hot water.
why?
because Q's positive.
I got to dump energy into it. What's going to happen to the volume?
The increase.
It's going to increase.
Increase.
So I would put this into a hot water bath, and you would see that get bigger.
2440 joules isn't a lot when it's in water.
Well, it's a small system, okay? But we also have to increase the temperature to 1476, which would be problematic in a
Oh,
hot
yeah.
water bath. Yeah. Okay,
Hot flame bath.
so
Lava.
if you go across,
You know if lava's that hot.
go way back up here. So if you go across like this is going to be iso
Thermic.
thermal
Thermal.
or ic, whatever you want to do. Okay?
Isothermal.
So what's going to be the
Thermal
sign of delta U?
Zero.
0.
No!
Wait.
Love of God! You
What?
just calculated it!
Oh,
Positive.
positive.
Positive!
Oops.
Hey, Berg. By the way, just
Isn't that for
as
iso-
for the funsies, you could just you'd be really close to get that temperature if you just dipped it in lava.
Okay,
Wait.
Noted.
so is Q a positive or
Interesting.
negative number?
Positive.
Like,
Q has to be positive.
It's negative. We just found it. It's
It's positive. We just found it. It's 2440.
Work is a,
negative.
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 because
Work
the
is
volume's getting bigger.
Oh yeah.
Now, let me give you all a hint. If there's anything you ever make flashcards on,
This.
isothermal, isobaric, isovolumetric, okay?
Positive
What's the
and
sign
negative
of Q?
signs.
What's the sign of delta U? What happens to your temperature? Okay? All right. Now, here's the last one. I always save the last one because it's the easiest.
Yay.
So now, I want to bring this line straight down. If I bring that line straight down, what's going to happen to your volume?
Same.
It's going to
Nothing.
stay the same.
So iso.
Ooh!
ISO
zero
volumetric.
So on isovolumetric, what's going to be the sign of my work?
Zero.
Zero. Why?
Because it's constant, so
Yeah.
there's no change.
So that
No
would be
change in
like I
temperature.
lock the plunger in place where it can't move. Okay? So that would be like Will's thermals. Okay? We're not going to change, we're not going to dent it, we're not going to crush it, okay? We're going to keep the volume the same. So, let me go way down yonder. Do a very, very quick sketch. So this is iso
Thermic.
thermal.
Thermal.
Thermic.
This is iso
Baric.
Wait, so was it delta like?
Baric.
Wait, was it delta U be positive isobaric or isothermic?
So on iso volumetric, okay? So,
It makes
this
it
point up here, what were the numbers for that last one? We had
2.
a volume of 0.5 cubic meters, what was, and the pressure of 2440, right?
Yes. Yeah.
Like 2.4
Yeah.
kilograms.
2.44 times 10 to the third.
So now I'm going to keep the same volume, but now I'm going to drop that pressure down. That's Newton's per square meter.
This is why I hate thermochem.
So now, I want to keep that same volume of 0.5 cubic meters. Let's drop the pressure down to 1,000 newtons per square meter. So, if you look at PV equaling nRT, what's going to happen to the volume side of this?
It's gonna
Nothing.
stay the same.
My NER is going to stay,
The same.
but what's going to happen to my pressure?
Decrease.
I'm going to lower my pressure, so the only way that can happen is if I
Lower your temp.
lower my temperature, right? Okay? So, if you look at P1, V1 over T1 equaling P2, V2 over T2. So what's going to stay the same?
Volume.
Volume.
Volume, so I don't have to worry about that.
Just
True?
P1 over T1 equals P2 over T2.
Yeah, so I got
Indeed.
P1
P2 equals P2.
times T2 equals
Photon equals
P2
P2.
times
Put to one
T1.
equals put to
Now
two.
I need to find that new temperature.
Photon equals P2.
Okay? So I divide by P1. So what was that T1 temperature, like 14 something?
Something like that.
What was that temperature up there?
Like
A number.
14, 11, so
Yeah, 1467 Kelvin.
1467.
And then that new pressure was,
Some nice liquid rock.
no, the original pressure was 2440. So, what should happen to my temperature?
Something.
Positive decrease.
It should decrease. Wait,
It's
you're-
different.
It'll be
Yeah.
new and improved.
Yeah, so somebody take 1,000 divided by 2440 times 1467.
611.
Yeah.
25.
What?
611.25.
Oh, I thought you said 0.25. I'm going, no way.
Almost absolute zero.
Okay,
That would be something.
now at this point,
That would be something.
can we calculate delta U?
Yep.
Yes.
Uh-huh.
We got 3/2 N, which is 0.1 moles, 8.314. Now, this is going to be change in temperature. So, what's going to be the sign of my delta U? Positive or negative?
Negative.
Negative, right? It goes from a hot
Well, what's my
temperature,
final temperature?
611, and it starts off at,
Minus 1467.
so that'll be all negative.
So that'll all be negative.
That's what I was saying.
So, what's the value of delta U?
Negative. Oh.
The value.
Negative 1067.
Negative 1,067 joules. Now,
I agree.
delta U also equals Q plus delta
W.
U. Also equals Q plus W. What's the value of my work?
It would be
What's the value of my
Wait.
work?
I'd say negative.
Negative 1,067 joules.
Wait, what's Q?
So that's delta U, and we know
It says
that
value.
Q
Always
is
give the sign.
Q is something. Probably
Did the
negative.
volume change?
I don't think so.
No. I don't
What's
think
the
so.
value of work?
Oh, zero.
Oh, zero. Oops.
I think it's negative. I said negative.
It's different.
No.
So, your delta U equals
It's
your
imaginary.
Q.
Q value. So, if I were to do this, ice bath, hot water bath.
Negative bath.
Negative back. Oh, there goes the syringe.
Everyone's sad.
Specifically Berg.
Time to be silent.
Give the thing silent. There's no more explaining.
Oh, we're cooked. It's another 18 questions.
I don't care what.
Okay.
Just keep in mind what you're gonna have on the final, and it's not gonna be that chemistry sheet.
Negative bad.
Okay, so let me give you some hints.
Oh, it's like the other one was.
So up there at the top, I've given you these conversions. So how a calorie, a lowercase c calorie, used to be defined was the amount of energy that it needed to take 1 gram of water and change it 1 degree Celsius. Okay, that's how a calorie was defined. So, but, and I got these numbers straight off of an Almond Joy when I was typing up this question.
Oh, I
So,
love
Do
almond
you have any
joys.
more?
Almond Joys are pretty good.
no. But, so here's the story. So, when you look at like food calories, by definition of the lowercase c, an Almond Joy actually has 230,000 lowercase calories, okay? But this became a marketing nightmare because it's like, man, people aren't going to eat an Almond Joy. That's 230,000 calories. That's bad. So they said, what can we do? Oh, we'll just lop off the last 3 zeros and put a C, an uppercase C on it. So that's, literally, that's basically it. They said, we don't want to mess with these zeros because that's a lot. So we're just going to lop off the lowercase last 3 and change it from a lowercase c up to an uppercase c. So
Nobody
that's
knows.
also then a kilocalorie, and that's 4,186 joules. So what I'm telling you on number 1, you consume an Almond Joy.
I
You
consume
take
a lot of
200, you
joules
take
every
in
day.
230 calories.
So 230 really means.
We're about 25% efficient. So of those 230 joules, we can only use 25% of those.
Which-
So just keep that in mind.
By the way, 25% is pretty efficient. We're doing in the
Oh, it's like a car engine.
in the biology world. That's
Now, when you get to number 8, you have 1 kilogram of ice at negative 10.
10%.
You want to warm that from negative 10 to 0.
Using roughly this many calories.
Melt the ice,
Almond Joys
warm
are-
the water from 0 to 100, boil the water,
Which question? They.
and then heat up the steam from 100 to 110. So you need to do 5 calculations. 2 of them involve latent heat, either fusion or vaporization, and 3 of them are going to involve Q equals M delta T C sub P. Okay? Pay attention to whether it's their specific heats for ice, for liquid water, and steam. You cannot use 4,186 for all of those because that's only for liquid water. When you get to question number 18, you need to use that work equals nRT natural log VI over VF. That's how you're going to use that one. Okay, good luck. You're on your own.
Do you have my test that I retook?